If you own a Subaru, then you most likely need a short block. And no, my car is not broken. This car actually has the exact same block that we are about to assemble. For one of you guys, if you subscribe and we hit 10,000 subscribers, my first 10,000 subscribers, I will make a list and I will give away this block or $3,000 if you don't have a Subaru, because I will be working on different cars. One of the video series I will be doing soon will be a right-hand drive Integra Type R, and that will be a content for you guys to look forward to if you're just into cars in general, not just Subarus. Subscribe and you'll have a chance to win this block. Once we hit 10,000 subs, I will announce the winner, and that winner will have the choice between this block or $3,000. Now here on the table, I have every single part, every single tool, every single seal, you name it, everything you will need to assemble a short block to be capable of making upwards of 500 horsepower. Now for the short block, everything on the table here is brand new. Pistons are new, wrist pin kit, seals, bearings, crank new, rods, even the cases are brand new. The beauty in that, with everything being brand new, we literally do not need to go to a machine shop. So we can assemble this block without outsourcing anything and going to a machine shop. If you're reusing your heads, then you would need to resurface them. That would be the only thing that I would say that you need a machine shop for if you're trying to assemble the whole block. Now you could skip all of this, not do it, and just buy a brand new short block from IAG out front. And by taking on a task like this yourself, you are saving yourself upwards of $1,000, and plus you get the experience and knowledge of doing something like this. And before you get crazy buying all these parts, the first thing you should do, if you were to go the same route as I am, buying every single thing brand new, the first thing you want to do is buy the short block itself. And the reason behind that is because you need your piston size. And your piston size is labeled here. So these letters indicate the size of the bore in the cylinders, and they range between A and B. So there's variations on short blocks where you would have an A in different positions versus a B, and they are opposing to that cylinder. So the position they are essentially in, where you're facing the block, is what that piston size would be for each cylinder. So this would be cylinder 1, 2, 3, and 4. And that is how you figure out your piston size. These pistons are sold individually by Manley. This is my second block doing this, and every time they come out precise. The measurements are always the same, and it's a very good quality piston. So on my block, I got all B-size pistons. So all four are equal, all four are the same. Now, the difference between the A and the B, I believe the A is slightly bigger. So aside from ordering pistons, you can order your block, your rods, crank, seals, bearings, and then your pistons. Now for the bearings, you can use a standard size for the main bearings and a HX standard. So this will give you an extra thousandths of an inch clearance on the rod bearings. Now for tools, here is every single thing you will need. You need a piston ring filer. This can be bought on Amazon. It's relatively cheap. I believe this one was like $20 or something. A micrometer that is between 2 to 3 inches. Another micrometer that ranges between 3 to 4 inches. And now you don't have to get the digital one. This is just easier to read. There are dial ones that are cheaper. You just have to kind of learn how to read them. Well, this bore gauge, I bought a digital one and I completely regret it because honestly, it's not worth the money. A dial bore gauge is sufficient for the type of measuring we would do. This is more if you can hook up a computer to it and have all the measurements go into like an Excel sheet. I don't think I'll ever use that, so I might just sell this. So do not recommend a digital one. At the end of this video, I will explain how much all of this cost and how much you'll actually save versus buying a complete short block, we're gonna start measuring our pistons. So the first step would be, when you buy this block, it already comes torqued. You wanna have the block torqued when you're measuring anything on the block. So that goes for the main bearings, your pistons, your piston rings, everything. Everything, it always needs to be torqued down for any type of measurement. Your rod bearings, when you put your rod bearings in here, you have to torque this down to spec in order to do your measurement. To measure our pistons, what I like to do, I like to use my vise. I put a microfiber towel in there. I grab my micrometer. I set that in here. Clamp it just snug. All of our pistons are grade B, so it doesn't matter which one we grab. If you had a grade A, you have to grab it for that specific cylinder. Now we're gonna verify our piston measurement. Essentially what we're doing here is we're just getting a benchmark for our dial bore. Now in order to measure these properly, you wanna put your micrometer at about the end. So where the lettering is for manly is where you want to measure. You don't want to measure it down here, and you don't want to measure up here. You want to be right where the lettering is. We're going to position our piston. I'm going to hold it centered on the lettering there, and then I'm going to tighten up our micrometer until I have no more slack, like so. Now, we got a 39136. So cylinder wall clearance and your piston size get marked accordingly. So for our first piston, and every other piston should be the same size. So it will be a 3.91336. So you could round that up and put a 4. I'll do the 3.6 and I'll check the other ones. Here's cylinder 2. Same concept. You could essentially go back and just literally feel out if there's any differences. Look at that. Same exact measurement. I'm going to do number 3. And here's number 4. Same size. We measured out every single one of our pistons, and we know that they're all within a thousandth of an inch. So this is a tenth of an inch, a hundredth of an inch, a thousandth of an inch. So the third number is what you're mainly looking at. So they were all pretty much consistent, so we will say they were all the same size. We're going to grab our bore gauge, and we're going to take this measurement of our piston, and we're going to lock this in so it doesn't move. So now what you do, you take your bore gauge, you put it in your micrometer, and what you want to basically do is zero it out. So you want to go and find the smallest number that you can get. And this is what sucks about the digital one. Alright, so I'm zeroed out. I don't get a number that's any more than 0. So now that I have that measurement in here, the concept here, since all of our pistons are essentially the same size, I can go through every single cylinder and check my clearance, my piston to wall clearance. So starting out at number 1, you want to measure. You don't want to measure where the wrist pin is. So the direction where the wrist pin goes, you don't want to measure like that. You want to measure where the skirt is. So when the piston comes in here, it sits in like this. So our measurement is off the skirt, not where the wrist pin is. The wrist pin side of the cylinder is actually smaller than where the skirt is. So picture the cylinder actually being like an oval. So it's bigger where the skirt is, and it's actually smaller, very small, like very slightly. It's smaller where the wrist pin would, the direction of the wrist pin. So you always want to measure the skirt side. You want to go like not up here. You want to be about a third of the way down. And then once you get there, you're basically moving this around and finding your smallest number, which should be 4 thou. And as you can see like we hit 44, right? So let's say 44 10 thou. Once I hit that, it will start to increase again. So my lowest number was that. So you don't, like I said, you don't want to look at the last two numbers there. You just want to worry about the thousandths of an inch. That's where it counts the most. So we are well within spec of where we want to be. 4 thousandths of an inch is essentially what you want for these pistons. These are about like a 4-inch diameter. It's usually like a thousandth of an inch per inch on a diameter of clearance. Same goes with the crank. Same goes with the rods. Thousandths of an inch per inch. So now that we figured out our pistons, or our piston to wall clearance, we want to file down our rings. Now for those that don't know this, pistons are labeled in their position from the front of the crank to the back. It goes 1, 2, 3, 4. And on the block itself, it's also labeled 1, 3, 2, and 4. When you get to this part, it's actually very simple. You have the top ring would be your compression ring. The ring in the middle is your oil scraper ring. And then this is your oil control ring, which consists of 3 different rings. The nice thing about Manley, they include the orientation of the rings on the diagram here. The oil ring has this lip to it, and usually you want that facing down. So you can see that lip, so that goes underneath and the dot goes on top. Now that we've figured out what our rings are, I'm going to start by putting in the compression ring first. And I'm going to put it in like this. And I'll simply just push it in like that, turn it, and then it's in there. Now, to square it off, grab a piston. I'm going to put it in until I feel like I'm squared off. So I'll get it, you can see it's rested in there, the piston isn't wiggling, so that's how you know you're square. If you were slightly up and you're still doing this, you're not square. So now we know that we're square. Our ring is perfectly set in there. This is where these guys come in. These are your feeler gauges. So feeler gauges, they range between many different thicknesses down to 1/1000th of an inch, right? And it's like paper thin. That's literally 1/1000th of an inch right there. The only thing that matters here, you don't want it too tight. Now, Manley does a pretty good job. They give you a equation basically on what your piston ring gap should be. So you basically take your bore size, now this is in inches, but by the amount of boost you want to run. So if you're doing like a high horsepower, 700 horse, I wouldn't recommend doing this unless you have a closed deck. But for our application, since we're still open deck, we're going to do high boost for 500 horse. So that means we'll take the bore diameter and times it by 0.0065. And that will give us our measurement for a top ring, our measurement for our second ring, and our oil ring rail. I mean, I'll check it, but I'm sure it's going to be within that spec. Coming back to our measurements here, to find out I know my bore size is 3.917 because our piston size was 3.913. And then you add the clearance, your cylinder to wall clearance, you add that up and you get your 3.917. So we want to times by 0.0065. And that is what our ring gap should be for the two top rings on every single cylinder. So again, just to simplify this, we just want to look at thousandths of an inch. So we don't want to look at all those numbers, we want to look at that. So that is what our ring gap should be. On our feeler gauges here, I have found our ring gap size that we want. Now, I know that this won't fit because we have to file down these rings. I guess just so we know for reference how much we need to take off, I'm gonna try a very small number. So we're like 13 right there. Still doesn't go in, so it definitely needs to be shaved a lot. What I will do, I will stay in the 20s. I want to stay in the 20s here, and then I will slowly file down that ring, and I'll keep checking it as I go. When filing rings, you only want to file, you don't want to file one side and then do the other. You want to file just one side. I like to have the top of the ring facing up as I file. So then it's just doing in one direction, and I know I'm doing the same direction every time I file it. When you place it on the file, you want to push it up against these dials, and then just have one side, like I said. I guess you just want to have, I'm on the other side here, so the other side is touching this disc. So, and I have some pressure, you know, like I can turn the ring like this. So then it's pushing up against this disc as I spin it, therefore filing it. Yeah, I'm gonna put a little bit of pressure and spin it. Now this process can take some time, but that's okay, because we got time, right? Hey, here's a little upgrade. If any of you ever have one of these, my recommendation is to ditch this stupid handle. So I took that out. So what my genius brain is doing, I'm essentially gonna put this screw in here, and I think you can guess what I'm gonna do next. Let's see how well this works. Ho ho, we're onto something here. Oh, yeah, this is correct. Numbers are up, we're square, and then simply, again, take our ring, place it in here, like so, push it in. Grab our piston again. So let's start in our 20s here. 23 fits. 24. Dude, there's no way. Did we get that first try? You're lying. That fits nice and snug. I'd say we're good. We're a little bit bigger than what we want to be, but that's okay. Now that we have our rings complete, now we are ready to start installing them to our pistons. Another thing that you have to make sure you do is position each piston opposing to each other. So Manley does a good job at this as well. They show you the direction on their guide here and their installation instruction. They even tell you where to measure the piston from. Remember when I was measuring the piston, I guess I should have pulled this out, but essentially your gauge point is right where I said where the letter is. But But getting back to the rings here, we want to make sure that our compression ring, our top compression ring, is on the bottom of the piston. So the direction of the piston, like this, it's upside down from where I wrote it, but the direction of the piston, you want to make sure that the top compression ring is on the bottom, and then your second ring would be on the top, and then I'll have to explain the oil control rings, but essentially the ones that sandwich the grooved ring, they have to be opposing on opposing ends, and then your expander ring can be within this range. Everything is very self-explanatory. You can't really mess this up unless you're not paying attention, but I will go through and show you on one piston. First, we want to start with this guy. Get him in here, right, like so. Don't worry about the orientation right now. You can position this after, because it is going to move around as you touch this thing. So for right now, we're not worried about the positioning of the gap or the opening of the ring, right? Until we get these two guys in there. So the first one, you can see the tab. I'm going to place the tab right. It's kind of tough with the camera. I'm going to place that tab right there, and I want it to go underneath like so, and I want to work this ring down into the galley, and just like that, it shouldn't really move out of place. Okay. So now those two are in place. Now we want to get the top one in. So this top one will go in this other groove. So you want to put it in there, right where it clips into that. Like so. And then work it going around. As you can see, that easily slides into place, and then it shouldn't move. And then just to double check, I'm sure you could see it right where my finger is right there. It usually goes like very smoothly up and down in like a wave, and then you can see a break in the ring. I hope that's easy to see. You just want to make sure that is on the bottom of the piston. But we can double check that after we put our compression in our scraper ring. In order to install these rings, you would need this tool. You can do it without it, but this just makes life a lot easier, because then you can just expand it like that. Now, you don't want to overdo it. We want this on the top, expanded, just like so. And boom, that's how you want it. You want it to move around. So now our compression ring, put in our compression ring. Again, make sure it's facing up. The lettering is right there. Open it. Put it on that top rail. And just like that. Now you can see they're lining up, so we can simply just rotate it to the orientation we want. And then that completes our first piston. So now our pistons are complete, all the rings are in there, we have them all measured out. We have our piston wall clearance, so we are done with pistons. Now we have to measure our bearings, and by doing that we have to measure our main journals and our rod journals on the crank. I've already done this but I will show you guys the process. You basically split your cases after this step, install all your main bearings, and then you're going to take a measurement off the crank. Same concept as we did with the cylinder walls. You're going to stick your bore gauge in there, and then you're going to measure the differences. And the key thing you got to watch out for is make sure you're measuring on the flat surface of the bearing and not like the groove. It's pretty much the same concept, so I'm not going to show the whole thing because I think it's not necessary, but it's pretty easy. So I'll just show one step, and then we'll measure our rod. That is the only one thing I have to make sure. And we'll put our rods in our crank, and then once that's in, we can start completely assembling everything. All right, as I mentioned, same concept. We use our micrometer. I guess I'll start with the rod since it's smaller. You basically just want to center it on the journal. You know, get it center as much as possible, and you can kind of feel it out to where it slides out with some tension. And now we have our measurement. I want to transfer it over to our bore gauge. Zero it out again. We take our rods. Now I already have a bearing in here. Like I said, I started this before. You need 0.02 of an inch of clearance, and we were at 1,000. So I needed to order another set of bearings, which is the HX, not the standard. So it's HX standard. This is just the standard bearings. I think that I've done this before on the gray hatches where the crank, the main crank journal's got the standard bearings, and on my rods I got the HX standard bearings for the rods, and that gave me my proper clearance that I needed. So I think ordering that bearing will be consistent. So just to show you guys, I will show you that this should be 0.1,000 of an inch different. And that's exactly what we got. You know what really grinds my gears is when I see people doing this. They go to torque down their rod, and some people put it directly like this, right? You're putting what was it? I believe like 60 pounds of pressure on these bolts. Therefore, you're like, I mean, I guess it's okay, but to me, I think of like flexing this, you know, like you're putting tension on this part and like trying to bend it like that in a way, I guess. To me, it doesn't take much just to drop this down even further to grab the rod right there. So then it's more sturdy and you're not trying to flex it on that arm. I'm gonna use my torque wrench here, but you're not supposed to. Dude, is that right? That doesn't feel right, you know? You know when something doesn't feel right? But it is. See, like, imagine putting that force. I just almost lifted my table. You're just putting on that skinny part of the rod. I find it very sketchy. Oh, how you doing? I like to take the bottom end of my hammer, I mean anything that's rubber really, and tap it out. So then I can safely get it out. And just like that. And then one thing to note, I'll explain this right now, is your bearings have these things called tangs. So you want the tangs to be facing the same direction, right? The same position. So they go like that. The other thing to look for is these numbers. You want them to be on the same side, because if you have them opposite, I mean, this was machined to be in this direction, so you have to put it back this orientation. So get that tang on that tang like that, and you'll be good. Now, when you get these, they come in this very hard plastic. Very hard. It's even hard to get it out of the package. Now, what I find is these are very flimsy. If you were to strain on this or like try to cut it here and scratch the surface of where your crank would ride, you might run into some issues. So what I like to do is just take the knife. This side doesn't matter. So you can score it like so. Right, I don't think I got it good enough, but I like to get it in from here. This knife isn't sharp at all. That was an epic failure. Oop. And then, you know, you could scratch the crap out of it. And it's easiest if you open it like I showed you. Because otherwise you'd be, you know, pulling on this stuff. You could potentially bend the bearing, and then that might not cause you an issue right away, but it'll definitely cause an issue down the road. And these do not matter, right? They don't matter where they go. They go anywhere you want. You pick and choose, mix them up, mix and match. Do what you want, do what you will. And then when you're placing them, when you're putting them in, you want to put the tang side in first, and then just slide them down. Right? You don't need to put oil on the back side, none of that. Just simply dry, tang to tang, put that tang on that tang, press it in, and then tang to tang again. Bada bing, bada boom, and then you put it together like that. Tap it. Then you're gonna put your bolts back in. All right. Don't do this. Do this. Yeah. Get it snug to where it doesn't fall. I don't know if any of you know how to measure, but essentially this is 3/8. And then just for the dummies, that's 1.5, right? 1/2, 1.5. And then, so then we have here 3/8, 1.5 is 60 foot-pounds. And again, this is included once you buy this stuff. And what did I say, 60? 60 foot-pounds, that's where we were, because that's where we left off. So now we want to tighten. We want to grab our 11 mil. This is a 12 point, by the way. 11 mil 12 point. I like to get it to like 30 on both. I can see it on my little screen. If you don't have a digital one, you could just kind of feel it out to where it's just tight. Right, so those both are 30 now. Now I'm gonna go the full length, or the full torque. We can measure our bearing clearance. You can see I slowly work my way down. And boom, 2000. We are pretty dead on. We have every single measurement complete. We can assemble our crank, split our cases, start putting every single part in. Make sure you use assembly lube when you're assembling. Really simply like to do. Doesn't matter, they're all the same measurement, every single one. Like I said, they're pretty consistent. This stuff is very goopy, as you can see. It likes to go everywhere. Essentially, just, you don't have to touch it, you don't have to spread it. Just put it in there. Place it where you're gonna put it. One thing you just gotta make sure, the easiest way to tell from the outside, the numbers. That is what I always look at, and that is what I find the easiest. So I like to put it in like that, and you don't have to touch it because once you put it there, it's already spread. Like watch, I'll see. I even took the bearing. The bearing stood in there, so I'm not going to show you guys. But just do that, and you're good. This stuff is very goopy. Do that. Make sure your number is lined up with the other number. Tang to tang, and you will be good. Put our bolts. Put them in with the drill first. Snug. Snugly. Sounds familiar? So now I like to put, this is where your crank pulley would be. This is your flywheel side, obviously. This is how I like to do it. You don't want to try to tighten it this direction because obviously it's going to slide that way. So you want to try to tighten it that direction, opposing to where, you know, you have it viced up or clamped. So in my case, it's going to be vertically. Oh, I pressed the button. Okay, so now 1, 2, and we're gonna beep. 1. And there we have a complete crank. So now we're gonna split the cases. One thing I will mention, this is a 1/2" socket. It will not fit in here, so you have to use a 3/8. 12 millimeter, 12 point, goes right in there. This is the same size socket, but on a 1/2" drive. It's too thick to fit inside the hole, so you can't use a 1/2". If you have a 1/2" torque wrench, you're gonna need an adapter no matter what. So now let's take this guy apart. To take it apart, sometimes it could be a challenge. I like to break them loose like that, starting from the middle. I don't really think it matters how you take these apart. Subaru purists will tell you otherwise, but I think it's more once it's assembled and you're trying to take it apart. But essentially you want to do a crisscross pattern. So start in the middle, go down, go up, go out, go up, and end there. So it's a crisscross. All right, so we did that, we did that. We do this one, yes. So we go outside. Bada bing, bada boom. Okay. Okay. And that's all of them. Fun part, which is always fun. I usually like to give it a couple bangs like that on my table. Kind of split them up like that. Slowly, shimmy, and boom, just like that. Now, one thing to be mindful is you don't want to scratch this surface at all. So whatever you have this block on, I like to put microfibers on it, just so it's sitting on something soft and not hard. Now, I didn't record this, but all of our bearing clearances on the mains are measured out, because it's like I said, it's the same concept as the rods, where basically you split the rods, you put the bearings in, torque it down, do your measurement, make sure you're within spec, and you're good. So same concept, except you're doing the torquing down pattern. It's a lot. You are about to witness it as I assemble it, but for right now, what I like to do is I like to put the crank assembly on 1/2. So the crank would probably go on this side because it has the O-ring galleys. So we're gonna put the O-rings in. Once we put the O-rings in, we'll put the crank in. And then on this side, we're gonna put our sealant. We have to seal this because otherwise you'll have a major oil leak. This doesn't have a gasket from the factory. This is just sealant. Another thing to note, the bolts that go inside the cooling jackets, right? So the bolts that go inside the cooling jackets, they don't have a regular washer. Like, this is just a steel washer. This would be on the outside of the case where you can see it once like the heads are in and stuff. So the ones that are inside the cooling jackets have this rubber O-ring. The box for some reason gave me this black O-ring, which I have never seen before. And it gave me this orange one outside. And I mean, they're essentially the same size, so I don't know if this was put in by accident or what, but thank you, IAG. These are all OEM from Subaru. All three of these are the same, so it doesn't matter where you put them. So your 3 O-rings, the 3 black ones, one here, another one here, and another one right there. Don't forget to put your assembly lube on each of the bearings. One more thing that's good to do before you put your crank in, it's good to, well, it's easy. It's easier if you put your seal in now versus trying to put it in after you put your cases together. So when you put it in, it easily just slides in like so, and you can position it to where it will be flush with the crank hub here. I gotta hold on to, since it's cylinder 1 and 3, I gotta hold on to 2 and 4 and slide it into place. I think something stopping it. Oh yeah. And just like that, you get your crank in there. And then usually you can balance these to where they stay up. I like to leave them so then they're ready to go. So once we put sealant on this one, we can simply just flip it up and over and slide it in. You can barely see this, but I use the Permatex Ultra Gray. This is the only stuff that we use on the mains or the cases. And I think it's about time I buy a new one because mine is not doing so well. Everyone has their own way of doing this. You do not want to get it inside those little holes there. You want to stay outside of that, not block those because the oil passes through that. You want to just get the outside and maybe the inside as well. Just kind of stay away from that area. You don't want to go crazy and get sealant inside that hole. But what I like to do is simply just rub the tip itself onto the surface, essentially acting as like a finger to put a very, very thin layer. I'm basically like brushing it on with this, as you can see. Some people like to do a bead. Some people do a bead and spread it with their finger. I like to just do this. I like to do this. You know? I like to do that. And then usually tough areas like that, I will spread it with my finger after, just to be on the safe side. You do not put any in the middle here. That is not necessary. You put some over here. And then some over in here. Okay. Now I'm going to put some right in here. Okay. Give it a decent spread. Make sure it's not on my bearing, because I don't have any leaks here. It's time. Right? We got everything in place correctly. Right? All the sealing. Everything's in place, man. Can't believe we're at this point. Actually, I can. I just can't believe how long it took. Make sure there's nothing on it. Later I'm going to clean these cylinder walls a little bit. And just like that, I'm going to start by putting a few of the bolts in. This side only has 2, and make sure you have the O-ring, the rubber O-ring on the bolt. Start it by hand. Make sure it's going in there properly. The 2 on the outside are very short on this side. The one that goes next to the oil pump. So now we know they're not going to split. We can simply rest it down like that. Put it on this face. Put these bolts in now. Again, with the O-ring. This goes on the outside with the regular washer. Sort them by hand. You want to start here, like how I did. We want to start here, and it's 1, 2, 3, 4. They get torqued to 7 foot-pounds. I'm gonna visually see that value on my little screen, 7, because it sucks, keep switching in between the measurements. I mean, it's just to slowly seat it down, really, because it wants you to evenly seat the cases together. So you want to make sure that you're doing the values low at first in the sequence that they want you to do. So then it goes again on this side, 7-ish. That's 1, 2, 3, 4, 5, 6. Okay. 7 foot-pounds. And then we want to go to 14. So it's 14 on these and 10 on these. So we're going to go till this beeps. Now we're going to monitor this one. 10. Beep. 10. Other side again. That's not good. So then I think it's like 90 degrees on the left side. All right, so now I'm gonna go flat. 90 degrees. Once again. 90 degrees. 90 degrees. 90 degrees. 90. 90 degrees. And that's it. So now that we got all that torque down, it's time to put in the pistons. Now to get our pistons in, we gotta lubricate the cylinder walls again. Lubricate our tool as well. Make sure our ring is in the correct orientation. One last thing. Before we put the piston in, we're going to put in our wrist pin clips, or clip. The front is here. This is the bottom of your piston, right? It has the direction. It'll tell you where to face this. If you were trying to put in this wrist pin, and you need to put in the clip on both sides, you need to think of how you're going to access, how you're going to access the other one once it's in here. You can't get it from the back side, and you can't get it from the front side. So before you put in the piston, you simply grab a clip and put it on the opposing side of where you have access. Like so. You always want to put this clip in first before you drop in the piston. Now it doesn't matter which piston you do first, because either way you're going to access it from the outside of the block, whether it's from the front or from the back for the other wrist pin. So I think we're ready to slide this guy in. And before we do that, we need our tool here. So we grab our tool, and it's lubricated. And what you want to do, you want to put your piston in there. Then you just gently tighten this guy up. It's tapered, so it's more open on the top and it's closed on the bottom. So then you want to kind of, I gotta loosen up a little more. You want to get your piston in here first, like so. And then give it a little tappy tap. And just like that, you got a piston in, man. You want to keep tapping it. You're gonna have to put a crank bolt in here because you're gonna start rotating this thing. You want to make sure that that rod, it won't stay for me, but you want to make sure that that first rod stays within that position, kinda, and then you want to tap down the piston. To where you were lined up. And I wouldn't worry about, oh, I'm a little off on that. Oh no. You could always spin the piston. You could spin it. To properly get it in there. This is where everything gets all greasy. So you want to grease it up like so. Slide that guy in there. Then with your needle nose, once again, you're gonna put in this clip and you gotta grab it at the very tip of it. So you gotta have some good teeth on it, otherwise it's just gonna keep slipping on you. And boom. And just like that, we got our first piston in. Look at that. So now we gotta do that 3 more times. All right, guys, so now we have, all right, so now we are at the final stage where we have the block completely assembled. All that's left for us to do is seal up the wrist pin holes. And all that is really is you buy this kit from IAG. Once you buy this gives you all the hardware you will need to complete that. And essentially here, for this cover, we put the RTV around this perimeter, and apparently where this arrow is, that's where you put this black bolt, and you'll notice that every single other one is like zinc coated. So that black one goes where that arrow is pointed on the block or on the plate. Oh, this is technically a wrist pin plug as well, along with these, so 4 total. This would cover one of these wrist pins on the block, and then with those you have to put in this crush washer along with it. So I know online some people kind of waste time and make a mess putting sealant on these threads. If you use a brand new washer, you will have 0 problems with leaks. Put the wrist pin cap in dry with the washer and you'll be fine. So now I got everything unpackaged and I have everything laid out so we have a better visual of what we are doing here. For these plugs, simply just put in this washer, and it doesn't matter what side you put it in, it works either way. And these are the easiest one to do first. So if you notice here, obviously your wrist pins go in there. All you do is put these guys in like so. So now those 2 are in, we're gonna torque them down to 50 foot-pounds. remember that gasket from earlier? Now I know I mixed up all the gaskets from the case halves. So the case half, if you noticed, it takes an orange one that's about the same size, and I completely forgot that this takes an O-ring as well. So that, good thing I didn't throw it away. My mistake there. It's, you know, it's been a while since I've done this, but now we know that we didn't have an extra gasket, and every gasket is in this block properly. So what you do, you take this O-ring, place it in here, and then you have 2 Phillips. And generally, you could only put this on one way. You can't mess this up, so don't worry about the orientation because you can't put it in wrong. One good thing with all these bolts in the back, I would highly recommend either using a blue or a red thread locker, just so nothing backs out. Now you don't want to put much. It's literally just a little dab, like so, and that's it. That's all you need. Now generally, like when I'm torquing something small like this, I just feel it out. And the general rule that I go by is when you tighten this up, once it stops pretty much, see, like right now it's, you know, it's snug. To me, that's what snug means. It's like when you're torquing something down and it essentially stops. So we'll do that to the top. See, I'm just using my fingers and it stopped. Okay? So now, generally, what it will be, it'll be like a quarter turn. And you can see, I'll do another quarter turn here, and I'll essentially torque it down. And that's it. That's all you really want. You don't really crank the hell out of it. You want to use a small ratchet as well for something small like this. And you can generally feel like when it's, you know, grabbed on there. And now that will never back out. On this side, you have a plug that goes in here. So you put this guy in first. 50 foot-pounds. And that's it. Now we're gonna put sealant on this perimeter. It's already like outlined for you. You just wanna put it on this mating surface so this will never leak. And just like that, that's what you want right there. We have our wrist pin plug torqued. Always make sure you do that step first. Just think of stuff like that when you're about to cover something up. Did I torque that? Just have yourself a mental note, or you could do marks. Either way, line up some holes, kind of press it in, and it should hold. And remember, the black one, it already has thread lock on it, so you don't need to add anything. The black one goes where the arrow is. It is a 4mm hex. Now I'm gonna put thread sealer or thread locker into these. There you have it, a complete short block with forged manly pistons, brand new crank, brand new everything. For one of you guys, if you subscribe and we hit 10,000 subscribers, my first 10,000 subscribers, I will make a list and I will give away this block or $3,000 if you don't have a Subaru. So I hope you guys enjoyed that one, and if you like the video, please like it, comment anything that I did wrong that you've seen, or just give me your personal opinions or your experiences. Tell me about your build. Tell me about your Subaru. Follow the channel, and I'll see you guys on the next one.